Here we are, week 5, SAT 22, with a multiple choice question concerning circles. Circle A shown is defined by equation quantity x plus 2 squared plus y squared is equal to 9. Circle B not shown is the result of shifting circle A down 6 units and increasing the radius so that the radius of circle B is 2 times the radius of circle A. Which equation defines circle B? All right, so before we dive into the solution, let's take a look at how we did. So when we have a multiple choice kind of question here, we're going to get a graph that is a pie chart, looks really, really clean. And the numbers here also look good. We can see that in blue, 78.4%, that's nearly 80% of the people chose answer choice A, which was in fact the correct answer. And if you look at the sectors representing the red and the orange and the green, those are the incorrect answer choices. They're almost evenly split. Okay. Now, with our follow-up question, how did you find your solution? You can see that the vast majority of people chose using Desmos. And it's almost the same percentage, which is interesting, the 77.8 versus the 78.4%. And I wanted to know if there was some sort of correlation between those two things. So what I did is I sorted our, basically the spreadsheet that houses all the answers there. And I looked at specifically the by hand and checked to see, like, what were the percentage of people that got it right versus got it wrong. So it turns out that about 60% of the people that chose to do this thing by hand, this is over half that chose to do it by hand, actually missed the question, which was an interesting outcome. Okay. And then finally, we thought that this question was medium, but skewed towards the easier side. As you can see, these larger spikes on the 1 and the 2 versus the 4 and the 5. Okay, so let's actually get into the solution. And I'm going to do this a sort of, whoops, this is the wrong thing, and it's this thing. Do this thing by hand first, and then we can take a look at some Desmos stuff. Okay, so the equation that they give us, which I'll highlight right here, is the graphed circle. And yeah, I get that you may have never seen the equation of a circle before, but that's okay. Especially if you use Desmos, then Desmos will just inform you of what that graph looks like. So we got x plus 2 squared plus y squared is equal to 9. So what I'm going to do is I'm going to examine the graph here, and I'm going to find some parts of this circle that I can compare to my equation here so I can draw some conclusions. So first of all, I'm going to notice that the center of the circle has coordinates -2, 0. So my center point is at -2, 0. And I think that that has something to do with the equation that we have right here, okay? And then also, we have a radius, and it's pretty easy to count up the radius if I just go something like this, and I can see that it has exactly 3 units for the radius. And that also has something to do with my equation. So my radius is r is equal to 3. And that has something to do with one of the numbers that is currently in my equation. So it turns out that the equation of a circle in general form looks like this. In parentheses, it's x minus h squared plus y minus k squared is equal to your radius squared. And specifically here, the h and the k, those parameters, that represents the center of your circle. And what I'm going to call your attention to is in the parentheses for the xy coordinate for the center h and k, they don't have the exact same sign that they have inside of the parentheses here, right? So it looks like it's negative here, but it's actually positive for the center point. And we can see that play out with our center point as well. This says -2, but notice that it has a different sign inside of the parentheses. It's a very common feature of graphs as far as translating things goes in the coordinate plane. And you may have some experience looking at that with, I will show you an equation in point slope form. So you remember this point slope form for equation of a line, not a circle. Point slope from algebra 1 look like this. I'll just give you an example. So let's say that it's y minus 3 is equal to a half times x plus 1, just made up at random. So we know that it has a slope of a half, let's say, right? But then it goes through the point -1, comma 3. And notice here that your x has an opposite sign, and so does the y. The way that we like to say this is that these x's lie, and, well, in this case, the y does too, but sometimes we see the y added over here, this 3 added to the other side, and it would be a +3, which matches up with this. So whenever they're paired up with the variable that they actually affect on the graph, then they actually do lie to you. All right, so there's one thing there. And what that is really going to point out to us is going to eliminate a couple of answer choices here. Some of the answer choices that you may have already picked, okay? Because what it's telling us to do, circle B, shifts the circle down 6 units. So if I'm going to shift this center point down 6 units, let me just count here. So 1, 2, 3, 4, 5, 6. Of course, it puts the new center point at -2, -6. So here's the new center. -2, -6. And so what some of us chose was to think that, okay, since I'm going down 6 here, on this y value, I should have -6. And you can see that that's 2 of these answer choices. But in fact, these are 2 answer choices that I would automatically eliminate. Because as we talked about, inside the actual equation, it would look like this. It would be a minus a -6, which makes it +6. So here's what the new equation should look like so far. New equation. So the new equation is x minus a negative, so +2 squared. So we didn't shift it left or right, so it should match up exactly with this guy. Plus quantity y minus a negative, so +6 squared. And then equals something over here that we haven't quite talked about just yet, but we'll get to that. Okay, so that gives us basically a choice between answer choice A and B, so a 50-50 kind of choice there. Okay, now look at the general form that I wrote down for you. You can see that at the end here, this is r squared. So believe it or not, this, if you squint down, you should be able to see that this is the Pythagorean theorem in disguise, which essentially it is. This is where the equation of a circle comes from. So I will just show you a sample of this here. If I were to select any point on the circle, I have no idea what those coordinates are because you can see it's in between some grid marks. I'd just be guessing here. But if I connect this to, of course, my center point, that's my radius. But let's say I wanted to find the length of that radius in the coordinate plane. Since it's diagonal, I would have to use a right triangle and the Pythagorean theorem, right? So I'm going to bring this thing straight down. I'm going to bring this thing straight across. And this r that's right here becomes the c in your Pythagorean theorem. And this would be your y part, and this would be your x part, which is essentially what's happening in your equation. This is like, I'll just write it here, like an a squared plus b squared is equal to the c squared. But our c is in fact the radius. You can see this here, so 3 squared is equal to 9. Okay, so let's go back to what it says in the words here. So we moved this thing down 6 units, which gave us answer choice A or B. And then it also says the radius is 2 times the radius of the original one. Okay, so if our radius, new radius, our radius was, r is equal to, what was it, 3? And I multiply that by 2, and I get a 6, a radius of 6. And then whenever I put this in over here, again, it's like our c squared in the Pythagorean theorem. This should be 6 squared, which is 36. Okay? And then whenever I look at my answer choices, there isn't an equals 36, but essentially that's what this 4 times the 9 is. This is equal to 36 when we multiply it. And so what it was doing is this, so 36. Is saying that since I'm multiplying my radius by 2, it would look like this. In parentheses, 2 times r squared, And then if you go ahead and use a power to the power product property for your exponents, this would be 2 squared, which is 4, times r squared, which is why we have this little 4 that's inside of our equation. Okay, so this shows us, again, by hand, as long as we know exactly what it is that we're doing, as far as transformations go in the coordinate plane, and maybe even some parts of some circles. Yeah, totally, we can do this without any kind of technology. I'm going to transition to that in just a second, but let's look at answer choice B. So on answer choice B, notice that it has these extra little 2's in here. And we might be tempted to choose something like B or even D with those 2's in there because we're going, oh yeah, 2 times bear. I'm just going to multiply this thing by 2. But here, let's put this into the form, the generalized form for the equation of the circle. Notice that the x minus h and the y minus k, they have a leading coefficient essentially of 1. Right, so they shouldn't have a number in front of it. So I'm going to do that with this equation. So 2 parentheses x minus, plus 2 squared plus 2 parentheses y plus 6 squared is equal to 9. And if I try to get it into this form, I just got to get rid of the 2's that are right up front. And I can do that by just dividing both sides by 2. So I divide everything by 2 over here, divide everything by 2 over here. And rewriting my stuff, of course, all these 2's on the left-hand side are going to cancel. I'm going to have x plus 2 squared plus y plus 6 squared is equal to, now the 2 over here, of course, doesn't cancel. And remember that this guy, is equal to r squared. So if I wanted to know what the radius is, I would take the square root of this. So the square root of 9 over 2. And I can simplify that just a little bit, not that it's necessary. Up top, that would be a 3, and on the bottom is the square root of 2. Anyway, all this to show you that this number is not 6, right? It is not twice the value of the original radius. Okay, so now, of course, there was only a handful of people that chose, I think it's like 24 people chose to do this thing by hand. Everybody else either phoned a friend. Oh, what's your answer? Oh, okay. Or they used Desmos. That was the vast majority of people, right? And so this is a pretty simple thing to actually do in Desmos. Okay, so this wanted to freak out, so let me just open. No, right? Sometimes the mobile version, like the graph of it, looks really wonky. Okay, there we go. Fixed it. All right, so I put some extra stuff in this little graph here for us, just so that you can see a couple of cool features. What I did is, in the little secrets tab here, I set this up so that I can have a radius, that I can move this little point around, so I can see a point on my circle kind of move around, and it actually gives me the coordinate of one of the points. Okay, but I can only do the top half of it, and that's just based on the fact that the graph of the circle is not a function, so I just set up in my little secrets folder there, basically the equation of the top half of the function. I challenge you to see if you can figure out how to do what I just did right there. Can you pull it off? Anyway, so once you have the original function, equation actually graphed here, I chose to put the center point on there so that I could very easily count up from my center to my new center here. And then in my little folder here, I just typed in all of my possible answer choices. And so here's the first one, answer choice A. And then here's its center point, and then here is its radius. And then, you just compare these. Looks sort of like a little snowman here or whatever, with his head's kind of going into the body. So maybe it's not a snowman. Anyway, so my new center point there adds -2, -6. I can definitely see that that is 6 down below the original one. And whenever I take a look at my radius and count those things up, I can see that this radius is 6, whereas the original one was 3, right? And that was probably it. After you got that first one typed in there, man, it fit the description. But just for comparison's sake, I'll show you the other ones. So I'll turn these guys off. I'll keep the same center point because answer choice B also had the exact same center point. So it at least checked that off, as then the center of the circle's in the right place. But we can see here that the radius actually shrank down and did not get 2 times bigger. So that one was off limits. And then here we have answer choice C with its center. And let's put our radius in here. So the problem with this one is that it translated our circle up 6 units instead of down 6 units, even though it has the correct size radius where it is 3 times bigger. And then finally, keep that one on here. Here is, whoa, here is answer choice D with its radius. And, oh, no, there we go, there we go. And it again translated our circle up instead of down, and then actually decrease the radius instead of increasing it, multiplying it by 2. Okay, so there you have it. A little bit of mini lesson on circles. I want to give you a sneak preview of all the stuff that is in the little secrets there. If you wanna, ooh, look at all that crazy business. Okay, that's good.